Good morning once again. Today this video is going to be my second video on the chapter ITF. Now today in this video we are going to start the exercise 2.1, which is totally based upon domain and range for a ITF. But before starting it, we need to be very cautious about some misconception. Like we have some misconception like, for example, what is the difference between sin x whole power minus 1 and sin inverse x? Somebody may think they're same, they're equal, but not at all. Why? Because sin x whole power minus 1 means simply 1 by sin x. It is the reciprocal of sin x, means it is the another trigonometric ratio, namely cosec x. But sin inverse x is an ITF, means trigonometric function. So please don't be confused between sin x minus whole power 1 and sin inverse x. They are not same at all. Sin x whole power minus 1 means simply 1 by sin x. It is the new trigonometric ratio, correct? But it is an ITF. Similarly, cos x whole power minus 1 means 1 by cos x. It is another trigonometric ratio, means sec x will come. But cos inverse x, it is an ITF. Similarly, tan x whole power minus 1 equal to the reciprocal of tan x, 1 by tan x. That means another trigonometric ratio will come, namely cot x. But here tan inverse x is an ITF. So in this way you have to remember, and so on. So please don't be confused between sin x whole power minus 1 and sin inverse x. They are not equal at all. Sin x whole power 1, cos x whole power minus 1, tan x whole power minus 1, these are a new trigonometric ratio because they are the reciprocal. But here they are the all ITF. Understood? So you have to be cautious in search of misconceptions. Okay. Before starting the exercise 2.1, we need to learn one more important topic, that is principal value for ITF. In short, we can say PP. PP means principal value. What is that? The values of ITF which lying in its range is called PP. That means we have to look for some angles within the range. It's called PP for the given ITF. The exercise 2.1 is totally based upon this PP and domain and range for a ITF. Now let us solve one by one. Then I hope it will be understood properly. Now let us see in the exercise 2.1 which questions are to be practiced. Now let us see one by one. First we shall practice question number 1, then 2, 3, 6, after that 8. Finally we shall practice 11 and 14. Here all the questions is about PV for a given ITF. You have to find the principal value for the given ITF. Now let us find them one by one. Now look at the first question to be solved, that is find the PV, means principal value of the following ITF. That means here you have to find the PV of this ITF sin inverse minus half. Now let us see how to start. Here the starting is very important. Understood? Let sin inverse minus half is x. Let that sin inverse minus half equal to x. We know already from the definition of ITF, if sin theta equal to x, then only theta will be sin inverse x. Correct? Already we have learned in the time of definition of the inverse. Correct? Similarly, in the converse way, we can say if sin inverse x is equal to theta, then only x will be sin theta, correct? Again, I am saying from the first. We know from the definition of the inverse ITF, if sin theta equal to x, then only theta will be sin inverse x. We knew it. From here, conversely, we can say if sin inverse x equal to theta, then only x will be sin theta. This value x will be sin theta. So finally, we have to use this concept here, correct? So here, see, sin inverse minus half equal to x, then only sin x will be equal to minus half, correct? So finally, we have got sin x equal to minus half. Now write down minus as it is. Now remember, sin what angle is half? Sin 30 is half, means sin pi by 6. Understood? So ultimately we have got sin is equal to minus sin pi by 6. Right? Now this minus sin pi by 6 can be managed as, can be written as sin of minus pi by 6, because we know sin of minus theta equal to minus sin theta, correct? Because you know sin of minus theta equal to minus sin theta. So this sin x equal to sin minus sin pi by 6 can be managed as, can be written as sin of minus pi by 6. So ultimately we have got sin x equal to sin of minus pi by 6, correct? So on comparing on both sides, we got x equal to minus pi by 6. So on comparing on both sides, we will get x equal to minus pi by 6. Now it is not an answer. Now it is not an answer. Now we have to check whether it is belongs to in the range of sin inverse x or not. If belongs, then it will be the required PV, required answer. Otherwise not. For this purpose, let us recall the range of sin inverse x. We know the range of sin inverse x is minus pi by 2 to pi by 2 close. So to remember the range and codomain, so please look at the table that we have made. Right? We know the range of sin inverse x is minus pi by 2 to pi by 2 close. Now we have to check whether this minus pi by 6 belongs to in its range or not. Now we have to check whether this minus pi by 6 belongs to this range or not. If belongs, it is the required PV, required answer. Otherwise, we need to modify to fall in the range. But here we see clearly this minus pi by 6 belongs to the range minus pi by 2 to pi by 2. That means here no need to modify. It is the required answer. Again I am saying, here we see this minus pi by 6 clearly belongs to this range, this interval. So it is the required PV. So likho finally. So the PV of this one, sin inverse minus half is minus pi by 6. That is the answer. Understood? So I am trying to say, after getting the value of x, we have to verify, we have to check whether it belongs to the range or not. If belongs in the range, it is the required answer, it is the required PV. Otherwise, we need to be modifying to fall in the range. But here it is clearly seen, this minus pi by 6 belongs to the range of sin inverse x. That means it is the clearly PV. Understood? Here minus pi by 6 is the answer. Now let us come to question number 2. In a similar manner, here you have to find the PV of the given ITF. That means here we have to find the PV of cos inverse root over 3 by 2. So let us proceed in the similar way like the previous math. Let cos inverse root over 3 by 2 equal to x. Understood? So in the similar manner, we can say only cos x will be equal to root over 3 by 2. Correct? Now remember, cos what angle is root over 3 by 2? Just try to remember the trigonometric table. Similarly, the cos 30 is root over 3 by 2. That means it will be cos pi by 6. Correct? So in this way, we are getting cos x equal to cos pi by 6. On comparing on the both sides, we can say x will be equal to pi by 6. Understood? So ultimately, we have got x equal to pi by 6. Now we have to check whether this pi by 6 belongs to the range of cos inverse x or not. If belongs, it will be the required answer. It will be the required PV of this given ITF. Otherwise, we need to be modifying. We need to modify to fall in the range. Now we have to check whether this pi by 6 belongs to in the range of cos inverse x or not. If it belongs, it will be the required answer. Now for this purpose, let us recall the range of cos inverse x. We know the range of cos inverse x is 0, pi close. Now look at the table of domain and range to recall the range of cos inverse x. It was 0, pi close. Now it is clearly seen this pi by 6 belongs to this interval. That means it is the required answer. That means it is the required PV of the given ITF. So likho. So the required PV of cos inverse root over 3 by 2 is pi by 6 because it is lying in the range of cos inverse x. Understood? It is the required answer here. Now let us come to the next questions to be practiced. In the similar manner, we have to find out PV for the following ITFs. Now here, I am skipping question number 3 and 8. They will be as a homework. Now we shall be doing question number 6, 9, 11 and 14. Now let us solve them one by one. Now let us come to question number 6. What is told here? In the similar manner, we have to find out PV for the given ITF tan inverse minus 1. So how to start first? Already we know. Let tan inverse minus 1 equal to x. Correct? So how to assume first? Tan inverse minus 1 equal to x. So from here we can say, like previous, only tan x will be equal to minus 1. Correct? Now write down minus as it is, and this 1 can be written as tan pi by 4 because tan pi by 4 is 1. So finally we have got tan x equal to minus tan pi by 4. Correct? This minus tan pi by 4 can be managed as tan of minus pi by 4 because we know tan of minus theta equal to minus tan theta. Correct? So again I am saying how to manage the minus. This tan x equal to minus tan pi by 4 can be managed as tan minus pi by 4 because we know from class 10 tan of minus theta equal to minus tan theta. Understand? Now from here we have got ultimately tan x equal to tan of minus pi by 4. Now on comparing we get x equal to minus pi by 4. In the similar manner we have to check, we have to verify this minus pi by 4 belongs to the range of tan inverse x or not. If it belongs, then it will be the answer. It will be the required PV. Now let us recall the range of tan inverse x. We know the range of tan inverse x each, minus pi by 2, comma pi by 2 open. Okay. Now look at the table. We know the range of tan inverse x is that minus pi by 2, comma pi by 2 open. Now it is clearly seen this minus pi by 4 belongs to the range of tan inverse x. The value minus pi by 4 is clearly belongs to the range of tan inverse x. So we can say it is the required PV. So we can say, so the required PV of tan inverse minus 1 each minus pi by 4. Understood? Because it is lying in the range of tan inverse x. That's why it is the required PV. Understood or not? Now let us come to the question number 11. Now let us come to the very important problem of this exercise, that is 9. Now the question may arise, why it is going to be important among all the maths. Firstly, look at the ITF. Here minus is given, firstly. And secondly, we shall be finding out the required PV in this case in some different way from the every other ITFs. Now let us know how it is different. Here in the similar manner, you have to find out the PV for the ITF cos inverse minus 1 by root 2. Correct? So let us proceed in the similar way. Let cos inverse minus 1 by root 2 is x. Correct? From here we can say similarly only cos x will be equal to minus 1 by root 2. So ultimately we have got cos x equal to minus 1 by root 2. So it is clearly negative because minus is happening here. Ultimately we have got cos x is negative. Now tell me in which quadrant the cos x will be negative. That we learned in class 11, correct? We know in the second quadrant and third quadrant cos x will be negative. In the second quadrant and third quadrant cos x will be negative. So it is clear from here the angle x either may be lying in the second quadrant or may be lying in the third quadrant. Again I am saying here we got cos x is negative. So it is confirmed here this cos x will be belong to either second quadrant or in third quadrant. That means the angle x maybe belongs to second quadrant or in third quadrant. But the problem is that if we take the angle in third quadrant, it will be crossing the range of cos inverse x. If we take the angle in the third quadrant, it will be crossing the simple range. That's why we cannot take the angle in the third quadrant. So it is cancelled. So it is clear the angle x will be belong to the second quadrant. Also it will be lying in the range. So we will go for second quadrant. So it is clear the angle x will be belong to second quadrant. Now this minus 1 by root 2 can be written as cos of pi minus pi by 4. Now look, this total angle will be belong to second quadrant. Also the value of sin cos pi by 4 is 1 by root 2. Correct? That's why we have taken here pi by 4. That's why we have taken here pi by 4, because the value of cos pi by 4 is 1 by root 2. Now we can check why cos pi minus pi by 4 is minus 1 by root 2. Already we learned it class 11. Correct? Now calculate. It will be pi minus pi by 4 will be after minus 3 pi by 4. Correct? So ultimately we have got cos x equal to cos 3 pi by 4. Correct? Now on comparing on both sides we got x equal to 3 pi by 4. Ultimately we can get after comparing x equal to 3 pi by 4. Now we have to check whether this angle belongs to the range of cos inverse x or not. If belongs, it will be the required PV, otherwise not. Now look at the angle 3 pi by 4. It is clearly seen this angle belongs to the range 0, pi, because the value of 3 pi by 4 is 145 degree. in degree. So it is clearly seen this angle will be belong to the range of cos inverse x, means it will be belongs to 0, pi. So it is the required PV of the given ITF. So likho, so the required PV of cosine inverse 1 by minus 1 by root 2 is 3 pi by 4. So here we have found the PV in some different way, though we have modified, and that's why I told you this question is little bit different from the every other ITFs. That's why this question is very, very important for you. Here we have modified the angle to fall in the given range, and ultimately we have got 3 pi by 4. Yes, it will belong to the range. Also, though it is maintaining the sign. That's why I told you this question is little bit different, and for these questions you need practice. Understood? Here we had cos inverse minus 1 by root 2 equal to x. So from here we can write only cos x will be equal to minus 1 by root 2, but it cannot be written as cos of minus pi by 4, because we know cos of minus theta is only cos theta. That means there is no effect of negative on the cos. That's why here cos is equal to minus 1 by root 2 cannot be written as cos of minus pi by 4. That's why here we have taken the help of quadrant. Understood? Now let us come to the question number 11. First let us see what is told here. Find the value of tan inverse 1 plus cos inverse minus half plus sin inverse minus half. Here it is clear the three ITFs are given separately. Understood? After the previous step, after the previous maths, we have found out the PV for separate ITF. But here altogether three ITFs are given. First we have to find their PV individually, and after that we shall be adding. That is the main work to be done here. Understood? First we shall be finding their individual PV, and after that we shall be adding. Now let us find them one by one. First, to find PV of tan inverse 1. So make the column in this way. Make the point in this way. In the similar manner, let tan inverse x equal to 1 equal to x. Let tan inverse 1 equal to x. So from here you can say tan x equal to 1. So this 1 can be written as tan pi by 4. Correct? So tan x equal to tan pi by 4. Ultimately we have got. I am showing directly. Already we got some ideas about the PV. Correct? So on comparing we can say x will be equal to pi by 4. And what was the range of tan inverse x? The range of tan inverse x was minus pi by 2 comma pi by 2 open. Correct? So it is clearly belongs to the range. Right? So you can say this pi by 4 belongs to the range. So the PV of tan inverse 1 will be pi by 4. So 1 is found. 1 PV is found. Now let us find the PV of the second ITF, cos inverse minus half. Correct? This one. Similarly, let us assume cos inverse minus half is y. Don't assume x. They will be different. So assume the different thing, that is y. So from here we can say cos y equal to minus half. Understood or not? Now look at here. Here the cos is negative. In which quadrant cos is negative? Either in the second quadrant or third quadrant. Correct? So the angle y may be lying in the second quadrant or in the third quadrant. but we shall be taking the angle in the second quadrant, because if we take the angle y in the third quadrant, it will be the crossing the range of cos inverse x that I discussed in the previous math. Understood? Now let us recall the range of cos inverse x was 0 to pi close, correct? Again I am saying, if we take the angle in the third quadrant, it will be crossing the range. Then we cannot get the PV. That's why we will not be taking the angle in the third quadrant. We shall be considering y in the second quadrant. So for this purpose, this minus half can be written as cos pi minus pi by 3, because cos pi by 3 is half. So this total angle belongs to second quadrant. So just let us do minus pi minus pi by 3. It will be 3 pi minus pi by 3 to pi by 3. Understand? In this way, we are getting cos y equal to cos 2 pi by 3. And finally, we got y equal to 2 pi by 3. Now let us check whether this angle belongs to range or not. Yes, it is clearly seen. It belongs to the range. So the PV, so it will be the required PV. So the PV of cos inverse minus half will be 2 pi by 3, correct? So in this way, we have got two PVs. The first PV was pi by 4 for this one. The second PV is 2 pi by 3 for the cos inverse minus half. Now let us find the last PV. Now let's find the last PV. To find the PV of sin inverse minus half, correct? In a similar way, let us assume sin inverse minus half is equal to z. Okay, so from here you can say only sin x will be equal to minus half. Understand? Now write down minus as it is. Here no need to be modifying. Just write down minus as it is, and this half can be written as sin pi by 6, sin 30, because we know sin 30 is half. So finally we get sin x equal to minus sin pi by 6, correct? Now this minus pi by sin pi by 6 can be managed as sin of minus pi by 6. Understood? Again I am saying, ultimately we have got sin x equal to minus sin pi by 6, and this minus sin pi by 6 can be managed as sin of minus pi by 6, because you know sin of minus theta is minus sin theta, correct? By using this formula. Okay, because you know sin of minus theta is minus sin theta, so we can say this minus sin pi by 6 can be managed as sin of minus pi by 6. So ultimately we have got sin x equal to sin minus pi by 6, correct? So on comparing, we can say x equal to minus pi by 6. So ultimately we have got x equal to minus pi by 6. Now we have to check whether this minus pi by 6 belongs to the range of sin inverse x or not. Now we have to check whether this minus pi by 6 belongs to this interval or not. Yes, it is clearly seen. This minus pi by 6 belongs to this interval. So it belongs to the interval minus pi by 2, pi by 2, which is the range of sin inverse x. So it is the required PV of this ITF. So the PV of sin inverse minus half is minus pi by 6. Understood? So I am writing all the PVs one by one. Firstly, we have found the PV of tan inverse 1 is pi by 4, correct? The PV of the second ITF cos inverse minus half was 2 pi by 3, correct? Similarly, now we are getting the PV of the final ITF, that is sin inverse minus half, is minus pi by 6. So tan inverse 1 plus cos inverse minus half plus sin inverse minus half will be now adding all the PVs that we got. Now adding all the PVs that we got in the previous step. 2 pi by 3 minus pi by 6. Understood or not? Now doing the LCM, 12, it will be 3 pi, it will be 8 pi, it will be 2 pi, correct? 9 pi by 12 means 3 pi by 4. That is the answer of this given problem. Understood or not? Now let us come to the last question of the exercise, that is 14. It is a MCQ questions, correct? Here we have to find out the value of tan inverse root 3 minus sec inverse minus 2. That means here we have to find the PV of the two given IFTs individually. Then we shall be doing minus, correct? Now let us find them one by one. First let us find the PV of tan inverse root 3. We know how to start. Let tan inverse root 3 equal to x as usual. Then simply tan x will be equal to root 3. So ultimately we have got tan x equal to root 3. Now tell me tan what angle is root 3? We know tan 60 is root 3. So it will be tan pi by 3. So the root 3 can be written as tan pi by 3. So ultimately we get tan x equal to tan pi by 3. Correct? So from here we can get x equal to pi by 3 on comparing on both sides. X equal to pi by 3. Now let us recall the range of tan inverse x. We know the range of tan inverse x is minus pi by 2 comma pi by 2 open interval, correct? We know the range of tan inverse x is minus pi by 2 comma pi by 2. Now we have to check whether this pi by 3 belongs to this range or not. If belongs, then it will be the required PV as usual. Now it is clearly seen here, this angle pi by 3 belongs to the range minus pi by 2 comma pi by 2 open, correct? So it is the required PV of tan inverse root 3. So you can say the required PV of tan inverse root 3 is pi by 3, correct? In this way we get one PV. Now let us find the another PV. Now let us find the PV of sec inverse minus 2. Now let us proceeding in the similar manner. Similarly, let us take sec inverse minus 2 is y. Don't take x again, take the another value y. So from here we can say only sec y will be minus 2, correct? So ultimately we have got sec y equal to minus 2, which is negative because minus is happening there. Now tell me in which quadrant sec is negative. Let's try to remember the class 11. We know from the class 11 that in second and third quadrant sec is negative. So it is confirmed here the angle y may be lying in the second quadrant or may be lying in the third quadrant, correct? So it is confirmed here the angle will be belongs to either in second quadrant or in the third quadrant. Understood? in which quadrant the angle y will belong, we can say particularly from its the range of secant base x. Okay, so in which quadrant the angle y will belong, we can say from the range of secant base x. So now let us take the range of secant base x. We know the range of secant base x is 0 pi closed minus pi by 2, correct? Now, if we take the angle y in third quadrant, it will be crossing the range. Then in this case, we cannot get the PB. That's why we cannot take the angle in the third quadrant. Again I am saying, if we take the angle y in the third quadrant, it will be crossing the range. So in this case, we will not get any PB. That's why the third quadrant is cancelled. That means it is confirmed the angle y will belong to second quadrant. Correct? So it is confirmed. So for this purpose, sec y equal to minus 2 that we got here can be modified as sec pi minus pi by 3. Correct? This minus 2 can be written as sec pi minus pi by 3. Now look at here, this total angle will belong to second quadrant and sec pi by 3 is 2. In this way, we can write minus 2. So minus 2 can be written as sec pi minus pi by 3. If you want, you can check the value. Always the value of sec pi minus pi by 3 will be minus 2. So it will be as homework. Because already we learned in class 11, correct? So ultimately we have got sec pi minus pi by 3 in the second quadrant. Just doing minus, it will be sec 2 pi by 3, correct? So ultimately we have got sec y equal to sec 2 pi by 3. Just on comparing it, y equal to 2 pi by 3. So ultimately we have got y equal to 2 pi by 3. Now you have to check this angle whether it belongs to this range or not. If belongs, it will be the required PB, otherwise not. Now you have to check whether this angle 2 pi by 3 belongs to this range or not. Yes, it is clearly seen. This angle 2 pi by 3 means 120 degree belongs to, it is the 120 degree belongs to this range. 0 pi closed. Also it is not pi by 2. So it is satisfying the range. It is lying in the range. So it is the required PB of the given ITF. So you can say, so the required PV of sec inverse minus 2 is 2 pi by 3. Correct? Understood or not? Already in the previous step, we have found the PV of tan inverse, that was pi by 3. Correct? The PV of tan inverse root 3 was pi by 3. Now we are getting the PV of sec inverse minus 2, that is 2 pi by 3. So tan inverse root 3 minus sec inverse minus 2 will be, put down the values that we got here, pi by 3 minus 2 pi by 3. So it will be 3 LCM pi minus 2 pi, correct? So minus pi by 3. So minus pi by 3 is the answer. That means it is matching with the option B. Understood? So here first we have found the PV of tan inverse root 3, that was pi by 3, and here now we are finding the PV of sec inverse minus 2, that is 2 pi by 3. After finding all the PVs, put here. It will be minus pi by 3. That is the answer. Correct? In this way, the exercise 2.1 has been finished almost. You know, this chapter is totally based upon some formulae. Here there is no so understanding. You have to remember some formulae, then you have to apply it. The chapter is about totally some formula. The chapter will run in the depending upon some formulae. In the next video, I shall be coming with some new formula, and also we shall learn how to apply it. Today I stop here. Thank you very much.